Alright, this is the very beginning of Unit 5, so we're on page 9 in your new book, so make sure you have the new packet of your workbook. So we're just going to start off with some vocabulary of this unit. So Unit 5 is all about identifying important parts of the quadratic function. It's also about graphing them. So before we can graph, we need to know what the parts of the graph are. So we're going to start with standard form. Standard form is the same as it's always been. So our standard form is still ax squared plus bx plus c equals 0. So standard form is still the same, where a, b, and c represent numbers. Okay. Next we have what's called a parabola. So it's not parabola, it's parabola. And the parabola is the graph or the curve that is made when you graph a quadratic. So it's just the shape of the graph. So these graphs, parabolas, specifically create U's. And we've seen parabolas before because we've been graphing quadratics even in Desmos at the end of Unit 4. Alright, so there's two different types of parabolas that we're going to talk about in this class. So if we graph this in Desmos, and then Desmos is going to give us a graph that looks similar to that, okay? And then if we graph the second one in Desmos, Desmos will give us something like this. So the shape of the graph is the same. They both are U-shaped graphs, but the first graph has the ends of the graph pointing up, and the second graph has the ends of the graph pointing down. So if you look at the two equations, really the biggest difference is that this one right here has a negative in front and this one does not. So remember, the number that is in front of the x squared is always a. So depending on if a is positive or negative determines which direction your graph is going to point. So if a is positive, like the first one, then that means that your parabola will open up like a smile. Okay, so smile is happy, positive. So if it looks like a smile, it's positive. If your a is negative, like our second graph, then that means the parabola opens like a frown. It goes down like a frown. Okay, so a determines happy graph or sad graph. Next we have what's called the axis of symmetry. So the axis of symmetry is the imaginary line, because it's not really there, but we could draw it on our graph. So it's the imaginary line that divides the parabola into two equal parts. So to show you what that looks like on the graph up here, the parabola is in two equal parts, which means when we draw this imaginary line, it's got a half our graph to where it splits right down the middle. Okay, so the axis of symmetry, we could draw down the middle of our graph, and we could find the axis of symmetry if we physically have the graph, but if all we have is an equation, there is a formula that we can use to find the axis of symmetry. And the formula that we would use to find the x value, we would simplify negative b over 2 times a. This would give us our x value of the axis of symmetry. And then to find the y, you would plug in the x value into your equation that you found here to find the y value of the axis of symmetry, because the axis of symmetry is going to give us the point in the center right here, which brings us to our next part of vocab. The second part we have is called the vertex. So again, the vertex is that point in your curve. So it's either, our curve can either be down here or our curve can be up here. Either way, the vertex is the point in the middle of the curve. So there's a couple of different ways to represent the vertex. We can either say that it is the point of change of the parabola, and that's going to make sense when we start talking about increasing and decreasing. So, because if we look at this example here, one half of my graph is increasing and the other is decreasing, and the point where it changes direction from increasing to decreasing is this vertex. It's also, in plane terms, just the point in the curve. So the point in the curve. And it is also, like I just said, the change from, I ran out of room, the change from increasing to decreasing. Okay, so the vertex is just the point, and like I said, it is a point, so that means it's going to have an x and a y. And if we look at the axis of symmetry, finding this x value using the formula and then plugging it in to find the y, these two are going to give us that point. Okay, next we have what are called a minimum and a maximum. So the minimum is where the vertex is the lowest point on your graph. So the minimum between these two, this one right here on the left, this one has a minimum because it is the lowest point that my graph will ever reach. Okay, so if we want to draw an example over here, a graph that is positive, this would be your minimum. Your minimum, if we write it as a point, would also be the same as the vertex because it is in the curve. Then we have a maximum, and this is where the vertex is the highest point. So if we look at our second graph above, this one up here, this would be our maximum because it is the max height or the highest point of that graph. So again, if we sketch it down here, the point that's at the top of the curve would represent our maximum. Okay, and then finally at the bottom of this page we have roots, solutions, x-intercepts. Remember, all of those words are interchangeable. They all mean the same thing. So this is just the points at which the graph will intersect the x-axis. And we talked about this at the very end of Unit 4. We looked at those on Desmos. So another word that we did not list here, but it also means these this definition. So we talked about it. It was also the zeros. So remember, roots, solutions, x-intercepts, zeros, it all means the exact same thing. Okay? So we're going to add one little piece that's not on here. At the top, we're going to add it right here in this box, and I'm going to use this left graph to demonstrate what I'm talking about. So we need to talk about increasing and decreasing. So I know you've done increasing and decreasing before as far as just identifying the graph as to where it's increasing and decreasing, but we need to write like an inequality to represent when this graph is increasing and decreasing. So the first thing you need to do is remember that the left part of your graph is going towards the negative numbers, and if we're talking infinity, the left side of the graph is going to represent negative infinity, and the right side of the graph is going to represent positive infinity. So if we're finding the increasing part of the graph, we read graphs from left to right. So if I'm coming from the left, this graph is going down to reach the vertex, okay? Which means this half of my graph is decreasing because I'm going down to reach the vertex. Once I reach the vertex, the right side of my graph is going away and it's going up, which means the right side of my graph is increasing. And so remember down here under vertex, I told you that it is the change from increasing and decreasing right here. So At this point is when I change from decreasing to increasing. So if we want to write increasing as an inequality or an interval, we have to start at this point. And increasing and decreasing inequalities or intervals are always using the x value. So let's say this vertex point is -1, -4, okay? So then that means starting at -4, I increase until infinity because my graph is going up forever. So this would be my interval of increasing. We can also write these as an inequality. So we looked at inequalities when we did domain and range, but we know that we start increasing at -4, and then remember that that's when we had the less than x less than, and then we don't stop increasing until we reach infinity, which is forever. Okay, so that would be my increase, how to represent my increase of this graph. So now if we're talking decrease, so we're decreasing, we write them the same way. So here, remember when we write at least the inequality or the interval, we always start with our smaller number first. So this graph, since it's coming from the left, we're not going to use positive infinity, we're going to use negative infinity because we're coming from the left. So my negative infinity has to go first because any number is going to be larger than that. And then I'm decreasing on this graph again until I reach the vertex, and I made a mistake up here, so I'm going to go back and fix it. But remember, I didn't even listen to myself, so I said that the increasing and decreasing use the x value, and so I should have used -1, and that is my mistake. So I'm going to fix it here. So we're decreasing from negative infinity to -1. Or another way to write that would be the same way as the inequality up here. So we start decreasing at negative infinity, and we don't stop decreasing until we reach -1. So I'm going to go back up here, and I'm going to fix this. I do apologize. So if you are watching this and you were like, oh, she made a mistake, I sure did, and I apologize. So anyways, x value. So this would be how you find the increasing and decreasing. So what I want you to do is, after you finish taking your notes, I want you to flip this page over. So when you flip this page over, it looks like this for page 10, and I want you to see how much you can do on your own as far as identifying the different parts that we just went over here. Let me know if you have any questions. Have a great day.